Okay, so today we will start a bit by just looking at the homework. Yeah, what we were supposed to do in the homework. Um, just a quick one so that we can just appreciate what. So here, the first question was talking about how deep is a pond if a bubble forming at the bottom of the uh, f- um, forming at the bottom quadruple their size in rising to the top. All right. So of course they are just playing with words here. Even if they had put it in Nyanja or in Tonga or in Bemba, or in English, nowadays, I'm sure you guys nowadays don't have a challenge with the language of English, because some of you guys, from nursery, you were taught English, but it wasn't the case with us. So I hope it wasn't the case of English, because English is almost now just like Bemba or Nyanja or anything, because people now are very familiar with English. So how deep is a pond if bubbles forming at the bottom quadruples their size in rising to the top? All right. So how deep is a pond? Let me try and just draw something, an illustration. So here is a pond, right? And there is water there. So you have a bubble. It's big like this at the bottom. But then, in fact, let me start with one which is small, because it starts to be small. So here is a bubble which is at the bottom, but as it starts to go up, it starts to increase in size. It starts to increase in size. Okay, no, wait. And then when it is at the on top there, this bubble is 4 times. So what it means to quadruple, quadruple is to become 4 times. Yeah, quadruple, quad stands for 4. This word quad, it's 4. Quadruple is it's like to become 4 times. If it is 3 times, then it is triruple. Then twice, is there triruple? No, there's no triruple. They would just say thrice or twice. No, not thrice, but thrice. If they say thrice, then 3, twice, 2, 4 times they say quadruple, and something like that. So yeah, so this was what was happening as the bubble was going up. So someone just to quickly tell us, why do you think here the bubble has a small volume? V1 is small, but V2 is big. The same bubble, there's the same air. It's not like someone was adding in air, but it's the same bubble. Someone to tell us, why do you think here at the bottom the bubble would have a smaller volume, but when it was going to the top, it had a bigger volume? Anyone to tell us quickly?
I think because on the surface, the pressure is less compared to the bottom. So as the pressure decreases, the volume increases. And as the pressure decreases, the volume increases, something like that.
Awesome. That's the way to go. That's the way to go. So here it's just the idea of pressure. All right. So here it's just the idea of pressure. Pressure increasing. So pressure reducing. You remember we know about pressure due to depth. If there's pressure in the oasis, in the pond, due to the water in the pond, we know that pressure is given by density of the liquid times acceleration due to gravity times the height. We get to have the pressure. So we can be able to calculate to write an expression for the pressure down here and the pressure on top here. Now on the pressure on top here, remember there is atmosphere. So in this case, The pressure on top here is the pressure of 1 atmosphere. All right. In fact, here you don't even need to write it in terms of atmosphere. You need to write it in terms of Pascal, because the pressure in terms of Pascal is the one that we use to calculate, especially even the depth of water, pressure due to the depth of water. We use the pressure in Pascal. So pressure on top here is about 1 point. All right, we know that the pressure of 1 atmosphere is about 1.0, it's about 1.01 3, something like that, times 10 to the power 5. We know that that's the pressure of 1 atmosphere. So this is supposed to be in Pascal. All right, so we know the pressure on top here. All right, and we know that the volume here on top, volume, maybe this is volume 1, or let's call it volume 2. Volume 2 over volume 1 is what? Is 4. So we know that the volume on top here is 4 times the volume here. We know the volume down here, so we know the volume. Volume down and volume on top is 4 times. We can just write it as expression. We shouldn't even write as V1 or V2. We should just write here it is 4. I mean here we can just put as 1, and then on top we can write 4 for the value of volume. So then we'll be required to find the pressure here, P1. By knowing, we know the pressure P2 there. We know P2, it's atmosphere, we know. So what is the pressure P1? If we find the pressure, then if we find the pressure, we know the density of water, we know the acceleration due to gravity. Then us, what we are required to do is to find the height. Is that okay? Can we manage to do that?
Yes.
Okay.
And personally, what confused me was, okay, I didn't hear what you explained before this. I got disturbed. But then I thought because we have a change in temperature, I thought our pressure was going to be constant. Yeah. So that's what
Okay.
made it complicated.
Okay. Or you have talked about you have talked about 2 things. You've said you didn't hear the expression prior to this. I thought you attended the last class, or if you didn't attend
Oh
the last.
no, like just right now in the lesson, I was disturbed for a short period of time.
Okay. So, okay. Again, yeah, there's an aspect of pressure, I mean, temperature. So, we also need to take care of temperature. No wonder yeah, so there's an aspect of temperature. So we should know the formula that has pressure and temperature and volume all together. I'm sure we know that. We know the formula of P1 V1 over T1 is equals to P2 V2 over T1, because also temperature is changing from on top. So we know we know the pressure P2 because it's 1 atmosphere. We know that we can calculate for P1 where it's coming from the bottom. We know V1. We know V2 is 4 times V1. We know T1. We know T2. So we should be able to find P1. We should be able to find, after we find P1, then we can be able to implement this equation and solve. So again, this formula, you can rearrange it in any way as long as you understand it. Yeah, you can arrange it in any way. And again, there's another thing. question 2 again. Question 2, most of you, one of you got it correct. So that's good. And so question 2 was talking about what volume of air at 100 kilopascal is needed to fill a tire of volume V. So the volume here, they have just given us V to a gauge pressure of 170 K. Assume that the pressure is the temperature. Here, question 2, the temperature is constant. So question 2, in question 2, with the formula that we'll be looking at is P1 V1 is equals to P2 V2. The pressure is constant. So what is V1? So V1, we'll just leave it like that, V1. What is V2? We'll just leave it like that because, in fact, V2, we can write it as V, what they have said V, all right? So that once we know P1 and P2, we can just write the expression for this V to be some number that we'll find, V1. Then we'll have our expression for this volume V. That would be, so all that they want sometimes is sometimes they want you to just make an expression. So they wanted us to just find, so even if they have said what volume is needed to fill what not. So to say that the volume that would require to fill a tire of gauge pressure 170 kilopascals is maybe 3 times the initial volume, depending upon this value that we found. So maybe it will be 3 V1, meaning it was 3 times the initial volume or 4 times the initial volume, depending upon what we find. But yeah, it's like that. And just a quick one again. One of your friends asked that why don't you give us some multiple choice questions, since they are the ones that we are usually given in our exams and quizzes and whatnot. So I guess what I can say about that is the idea, of course, is not, the idea is to get the concept. So here, when we are talking about thermophysics, what you should be striving is to understand exactly what is happening, how pressure, because they may give you a concept question in the quiz about maybe if the pressure doubles, what will happen to the volume, given that the temperature is constant. If the pressure doubles, right? If the pressure doubles, will the volume double also, or what will happen to the volume? So if you have known the concept, all right, and knowing that my formula for pressure and volume is like this, if P1, my pressure for P2 becomes 2 times P1, I know that what will happen is if my pressure doubles, my volume will decrease by half. You see? So those are some of the concept questions they can ask, but the whole idea is you have to grasp the concept. Don't memorize these equations. These are the ones which I give you, P1 V1 over P2 V2. Of course you can memorize them, but the idea is know why we are saying so, especially with these concepts that I was giving you. When I could tell you that pressure and temperature are inversely proportional to each other, you should know what it means. So meaning if you increase pressure, temperature will also increase. All right, that's what it means, proportional. But when we talked about, what else did we say? We also said, I just want to look at, yeah, we also said volume and temperature are proportional to each other. So if we increase volume, temperature also increase. So, but again, we know that pressure and volume, or should I say pressure and volume is inversely proportional to each other. So pressure is inversely proportional to volume. So meaning if I increase the pressure, volume will do what? Will reduce. So we should be able to get some of those concepts in us. And if we have those concepts, no matter how they may phrase a multiple choice question, you have a foundation, a basis where you can answer them. Is that okay, friends? Hello?
Are you done
Yes.
with that? Is it question 2 yet done?
Yeah. We are done with explaining question 2.
What's the final answer, please?
And no, we are not solving. I was just explaining how to go about it. Even question 1, I didn't solve it. Even question 2, I didn't solve it. It was just explaining because it's a homework. If I solve your homework, then it won't be a homework anymore. So you still have to go and solve it. But I just wanted to give ideas. Is that okay?
Yes.
Okay, so Mr. Gilbert, you joined us on the way. I hope you'll be able to follow through as we go on, and I hope you are doing fine this afternoon.
All right. But I have a question just there, sir.
Uh-huh.
Yeah. There's the issue of gauge pressure and the pressure. I saw somewhere something like in the notes like pressure is equal to gauge pressure plus pressure the atoms exert. Now they solved a certain question and then it was like they gave the gauge pressure and then they just gave atmospheric pressure. And then when finding first as in P0, they added the 2. And then the question was to find something like gauge pressure at maybe a certain another phase of temperature. But they just found the pressure which they found after using the initial pressures in the gauge pressure plus the atmospheric pressure. Now, my question is, where are we not supposed to again subtract atmospheric pressure from the pressure we find as in the final, just to find it, for example, if we are finding gauge pressure in such a case? I don't know if you have gotten it properly.
Okay, awesome. And just a small one. This is not gauge pressure, it is gauge pressure. So of course, just for the sake of, you are a scientist and you'll be giving scientific speeches, and then you stand in front of people, you say gauge pressure, they'll be wondering what is gauge pressure. It is not gauge, it is gauge pressure. Yeah. So gauge pressure, all right. So let me give an example of this, which this pond that we have here. All right. So this pond that we have here, inside this fluid, all right, there is pressure due to height, right? Pressure due to height. All right. But on top of the fluid, there is atmospheric pressure. So usually when we are here at the bottom, the pressure that we experience at the bottom will be the pressure of the atmosphere, ATM, atmosphere. It will add plus the pressure, which we calculate due to height, as that. All right. So if I'm to find pressure here, it's because the atmosphere, which is on top, has some pressure, which is it is exerting on this surface, like that, such that the pressure that I'll have here at the end of the day will be the pressure of the atmosphere plus the pressure due to the height, to the depth of the liquid. All right. Even in this question, for example, this formula that I gave, we are saying pressure 1, pressure at the bottom is what we want to find first. Once we find that pressure, if we want to relate it to the pressure due to depth, we should try and first forget about the pressure of the atmosphere. Because this formula that I have here, rho GH, density times gravity times height, this formula does not put into consideration the atmospheric pressure. All right? This formula doesn't put into consideration the atmospheric pressure. So if I found my pressure, this P1, which we have here, even in our calculation. So if I found my pressure to be, for example, 2, or to be, for example, 3 times 10 to the power 5. If I found the pressure here, this P1, to be 3 times 10 to the power 5 pascals. When I'll be using this formula, I will not use this pressure, because this pressure has atmospheric pressure in it. Because here at the first instance, we are calculating P1 to be at the bottom, P2 to be where atmospheric pressure is. So this pressure has atmospheric pressure in it. To use this formula, we'll use now, we'll subtract the atmospheric pressure, because this formula only deals with the height or the depth of the liquid as we go down. That's why there's this H. So since this formula only deals with the density times gravity times H, then what I would do is the pressure that I'll find, I will subtract atmospheric pressure. So the 3 point maybe 1 or something like that times 10 to the power 5, I would need to subtract the atmospheric pressure. All right, atmospheric pressure. We know that atmospheric pressure is about 1.03, something like that, Pascal. So why am I subtracting again? Is because of the formula that I'm using to find the height. The formula that I'm using to find the height does not put into consideration the atmospheric pressure. So what is gauge pressure then? Gauge pressure. So if I have pressure gauge, all right, gauge pressure is the pressure which does not consider atmospheric pressure. So it is as pressure. So if you have found, for example, if you have been told to say the gauge pressure is this, meaning that gauge pressure does not have atmospheric pressure in it. So if you want to find the total pressure, if they say what is the total pressure in any case, meaning that pressure which I'll find, the gauge pressure, I'll need to add the atmospheric pressure. I would need to add the atmospheric pressure. So this is my gauge pressure. This is my pressure. But if I add them both, then I'll find the total pressure. Total pressure. All right. So I guess that's my explanation. So no matter what they did, whether they subtracted what, whether they did what, just have at the back of your mind that gauge pressure is pressure where there's no atmosphere. But if I'm getting my total pressure, then my total pressure should be my gauge pressure plus atmospheric pressure. So here in this case where they said, what is the volume of air at 10 kilopascal is needed to fill a tire of volume V to a gauge pressure. So here they've given the word gauge pressure. So this pressure is just the pressure in the tire without considering atmospheric pressure. All right. So you can even do your calculations just like this without even adding atmospheric pressure. As long as here on the first instance, if here you don't add the atmospheric pressure, even here you can choose not to add atmospheric pressure. So if you are calculating P1 and P2, P1 you add atmospheric pressure, P2 you don't add atmospheric pressure, then your calculations will be 40. But in any case, make sure that if you are dealing with gauge pressure, just deal with gauge pressure. And if you are dealing with even adding atmospheric pressure, just do, if you are dealing with gauge pressure, just deal with gauge pressure. If you are considering atmospheric pressure again, then you can also consider it, so that you can find your answers correct. I don't know if I'm making sense. Is my explanation okay?
Yeah, I've understood that better.
Yes.
Okay. So what is going to happen is I'm going to end this meeting so that we come back, so that we can solve some more questions for today. We'll just spend a few minutes. I didn't expect us to spend so much time here, but yeah, so you can go back to the link so that we continue.